So we are going to be going over the exponent rules, and we are going to start with the exponent of 1. What does it mean to have an exponent 1? Think about it like this. 5 to the first power is equal to 5. 7 to the first power is equal to 7. 12 to the first power is equal to 12. And so, once you get into algebra, you may see something like x to the first power. And we know, based on this pattern, that this should be equal to x. So sometimes when you see just x, you should always remember that there is an invisible 1 as its exponent, as with every other number. 12 has an invisible 1 as its exponent, 7 has an invisible 1, and so on and so forth. That is the exponent rule 1. You may also be dealing with the product rule. And the product rule comes when you're multiplying things with exponents. For example, 5 to the first power times 5 to the first power. Well, 5 to the first power is 5. And so this becomes 5 to the second power. Because exponents are essentially telling us how many numbers we have with multiplication. So because there are 2 numbers with multiplication, we're raising it to the second power. So now you have 5 to the second power. And so if you want to continue, 5 to the second power times another 5. You have 2 5s here and another 5. So we end up with 5 to the third. Because guess what? There's an invisible 1. Alright? So because you have that, what are we actually doing here? What are we actually doing here? We add the exponents. Alright, so if that's the case, let's go through a more tricky example. Something like 5 to the third times 5 to the second. If we're following this rule, we must add to get 5 to the 5th power. Exactly. Great. So, if you guys are understanding that, now let's throw in a little bit of variables. Suppose we have x to the third times x to the second. We end up with x to the 5th power. Suppose we have something like y to the 10th times y to the second. Of course, you guys know if we're following the same pattern, we end up with y to the 12th. Alright, because 10 plus 2 is 12. Now, let's take a look at an even trickier example. What should we do if we have something like x to the 10th times y to the 5th? What do we do there? Take a moment. How is this different than the other examples? Well, they all are using the same number. These are using the same variable, okay, the same letter. And now here we have different variables and different letters. So guess what? We can not simplify. That is how you use the product rule of exponents. So we're going to now move on to the quotient rule. Alright, so for the quotient rule, this comes when you are dividing exponents. So I'm going to put a little division here. Yes, I had to switch out my marker because the last one was dying. So sorry about that, guys. So again, quotient rule is when you are dividing. So let's take a look at a nice simple example. If you have 5 to the 7th power divided by now 5 to the 3rd. Well, one way you could think about this is really 5, 5, 5, 5, 5, 5, 5. There are 7. This is really 3. And so how can we think about simplifying? Well, this 5 can cancel out with this 5. 5 divided by 5 is just 1. So it's just 1. This 5 cancels out with that 5. And then this 5 can cancel out with that 5. And so, what do we end up with? 5 to the 4th power. Okay? Let's take a look at one more example. Alright, let's say we have 7 to the 8th. No, that's a pretty big number. I don't want to use 8. Say we have 7 to the 5th and 7 to the 2nd. Now, who can guess? Let's see. Take a moment to think about what this might be. Well, following the same strategy above, we have 7, 7, 7, 7, 7. We can divide that by 7. 7. These will cancel with each other, and we're left with... Now, what are we actually doing here? We are subtracting the exponents. And so now let's take a look at a more complicated example. Let's say we have x to the 5th divided by x to the 2nd. If we're subtracting, then this will be x to the 3rd. Again, if we have x to the 7 divided by y squared, guess what? Different numbers that we're dealing with, so we can not simplify. And that is your quotient rule. Alright, so now we're going to go over the zero exponent rule, and this is one of my favorite rules. I really like it just because it comes from the division rule in terms of understanding it. So the zero exponent rule is basically what happens when you have a 0 in your exponent. So let's say we have 5 to the 0 power. Well, that actually equals to 1. Whoa, you guys are probably like, wait, how does that equal to 1? Well, I'll show you. But before I show you, let me do another example. 7 to the 0 power equals to 1. Yes, it does. Then we can have 12 to the 0 power. And guess what, guys? That's also going to equal to 1. Now you're probably wondering, how? Well, what is the rule first? Anything to the 0 power equals to 1. So I'm now going to explain to you why this is the case, and I'm going to explain it. So, and I'm actually going to be referencing the quotient rule that we just learned. So take a look at this. Imagine you're using the quotient rule. 5 to the 7 divided by 5 to the 7. But what does the quotient rule tell us to do? Subtract. Well, what is 7 minus 7? Well, it gives us 0. So, now what is 5 to the 0? We know that's equal to 1. But how is this equal to 1? This is equal to that. Well, anything divided by itself is always equal to 1. Exactly. Anything divided by itself will always be equal to 1. And so if you have 5 to the 7 divided by 5 to the 7, that should equal to 1. But it's also 5 to the 0. The same thing will apply with any other number. X to the 8th. X to the 8th, well, we know dividing by itself equals to 1. Using the quotient rule, it equals to x to the 0. So anything to the 0 power will always give you 1. Lastly, we are going to learn about the negative exponent rule, and this happens when you have a negative exponent. So I'm first going to show you a situation where a negative exponent might arrive. starting with the quotient rule. So if you think about the quotient rule, imagine you have a situation where you have x to the third divided by x to the fifth. So you'll notice that we do have to subtract here. And when we do our subtraction, we're going to have 3 minus 5. Well, 3 minus 5 is equal to a negative 2. So this will leave us with x to the negative 2. Now, what does it mean to be x to the negative second power? Well, let's do our expansion here, how we usually do, and 5 in the bottom. And then we start to cancel. What are we left with? Well, there's an imaginary 1 here, right? And then on the bottom, we have x squared. So this becomes 1 over x to the second power. That's what it means to have a negative exponent. So let's take a look at a second example just to get the hang of what's really going on here. What if we had x to the negative fifth? Well, if we're following this rule, the shortcut, this is our shortcut, we're going to end up with x 1 over x to the fifth power. The long way will be to say, well, x to the negative fifth can come up when you have something like x to the fifth over x to the 10. All right. And then we'll have 1, 2, 3, 4, 5, and then 5. And then these will all cancel with each other. And the other 5 will still be there with the 1. And you'll get 1 over x to the fifth. So this is your negative exponent rule. And I hope it makes sense to you based on the quotient rule. Finally, we're going to end this video off with the addition rule. So I'm actually going to put some question marks here because I'll show you. There actually is no addition rule, but you do want to consider the case where you are trying to add. Let's take an example of 5. Let's say x to the fifth plus x to the second. Now, you actually cannot simplify this. But what you can simplify is if they have the same exponents. You can combine them. Say we have x to the fifth plus x to the fifth. Well, actually, in this case, they combine to give us 2x to the fifth. And that's when we're dealing with coefficients. So we're not there yet. We're not going to be dealing with coefficients here, but this is simply combining like terms. The same exponents, you're actually combining your like terms. So guys, I hope you enjoyed learning about the exponent rules. If you need to, you can always come back to this video to refresh your memory of where all the exponent rules come from. But for the most part, these are the rules that you need to know in order to do well in algebra. Alright, so they are very fundamental, and stay tuned for the next video where we'll talk about the next thing you need to know if you're going to be sitting inside an algebra class. And don't forget to subscribe to this channel, and don't forget to leave a comment in the comment section and let me know if this video was helpful. Let me know which parts were kind of confusing. I always love feedback, and that way I could just make a new video explaining it in a different way, and then that way it could help someone else. So I don't mind having multiple videos with the same thing. So just leave some feedback and I can create a new video. I really don't mind. So thank you so much for watching, and I'll see you in my next video.